Hi everyone and welcome back to my channel. In this video, we will be discussing exercise 1.2 of your chapter 1, which is number systems. So let's get started. We have exercise 1.2. Now, what is the first question in this? The first question in this is again to verify all the statements given are true or false and with proper reasoning. So every irrational number is real. Now, is that true? Is that true? Is this statement true? Yes, it is true. Why? Why? Because what are irrational numbers? Irrational numbers are numbers that cannot be represented in the P by Q format, right? So now that we cannot represent irrational numbers in the P by Q format, some examples are what? Examples are root 2, root 3, pi, and so on, right? These are all irrational numbers. And what are real numbers? Real numbers are basically the collection of all rational and irrational numbers, because they're all real, right? Irrational numbers, they're all existing. Therefore, all rational numbers and irrational numbers together are known as real numbers. So like examples are 1 by 2, root 2, and so on. So all numbers or all rational and irrational numbers are real numbers. Therefore, yes, every irrational number is a real number. Now that was the first point. Moving on to the second given statement. So every point on the number line can be represented in the form of root m. Is that true? It is not really true, right? Okay, he's given that m is a natural number. So m can be 1, 2, whatever, right? So some numbers can be represented, like for example, you have 2. 2 on the number line can be represented as root 4. Similarly, 3 can be represented as root 9. But can a number like pi be represented as a square root of a natural number? No, right? So basically pi is what? 3.14, and it keeps on going, right? You can't represent this number as a square root of a natural number. So therefore, this is one example where we cannot represent a number on the number line in the form of root m. Therefore, this statement is false, right? So even though we can represent some numbers like 2 and 3, we cannot represent other numbers like pi. Therefore, we cannot represent all numbers on the number line using the form of root m. Okay. Now, moving on to the third statement that is given in this question. Every real number is irrational. This is directly false, right? What is a real number? A real number is real numbers are the set of numbers which have both rational and irrational. So this real number set has rational numbers like 1, 2, 3. It has irrational numbers like pi and so on. Therefore, all these together form real numbers. Therefore, all real numbers, like for example 2, 3, etc., are not irrational. Therefore, all real numbers are not irrational. Therefore, every real number is not irrational, and this implies that this statement is false, right? Now, moving on, let us go to the second question of this particular exercise. So, are the square roots of all positive numbers irrational? Are square roots of all positive numbers irrational. If not, provide an example of a square root of a number that is not an irrational number. So this is a pretty simple question because you have so many examples, right? So simple examples would be any number you can take, any number square you can take. Like for example, you have 2, you can take it 4. So the square root of 4 is what? It is 2, right? 4 is a positive number and positive integer rather. So 4 is a positive integer and 2 is its root, which is not irrational, right? So this implies that root 4, which is where 4 is a positive integer and its root, which is 2, is not irrational. It is a rational number. Therefore, this implies that no, all square roots of positive numbers are not irrational. Okay, moving on to the third question. They are asking us to represent root 5 on the number line, right? So how do you represent root 5 on a number line? Represent root 5 on a number line. So let us take the number line like this. You have 0, 1, 2. Okay, let's keep it a little bit longer. 3, 4 and 5. Where would you place this particular number? Right, where would you place it? Root 5 come, 2 is there, root 4 is basically 2, right? Then you have root 5, then you have root 6, root 7, root 8 and root 9. Root 9 is what? 3. So this implies that your root 5 will be somewhere in between 2 and 3, right? So now what would you, now somewhere in between 2 and 3. So therefore it will be somewhat like this, right? So this is how you represent root 5 on the number line. If you want to make it more accurate, because in the exam we need to show the process or the procedure of how we can do it, we need to follow the method that we have used in the examples. You can use this particular method that we just used to verify your answer, but as we did in the examples, we need to follow the Pythagoras theorem method, right? So how do you represent root 5? Root 5 is nothing but root 4 plus 1, which is what? Which is nothing but 2 square plus 1 square under root is equal to, we want to represent a, right? So let's say a. So 2 square plus 1 square is equal to a square. Okay, so that implies that you have a, let's say this is our number line and we draw a vertical line at 0, right? So you have your 1, 2, 3 and 4. Okay, so what you want is root of 5. Root of 5 is root of 2 plus root of 1. So you can either put your horizontal axis at 2 or at 1, and from here a vertical length of 1, right? Now this will be the length of root 5, right? Now you take a compass and with this particular length as the arc distance, you draw an arc on the number line which will be of the same distance. Now why is that? Because the circle's radius or the arc's radius is constant. This particular point will be root 5, right? So So this is the method that you will have to do it in your exam to show the answer. But we can verify that it is between 2 and 3, and here also we have gotten our answer between 2 and 3, which means that our answer is correct.